So good afternoon. It's my great pleasure to be here with you at Computex in Taipei with such an esteemed group of industry colleagues and leaders here. And what I'm going to talk to you about today, you've heard kind of our first couple of speakers talk about the things in the Internet of Things. But there's another part of the equation. It's what those things connect to. And that's what I'm going to talk to you about today. We think that there's a parallel in the IoT universe. It's the evolution that needs to occur in the network to deal with that. So first, to talk a little bit about what are some of the fundamentals that we see from a computing capability from an IoT perspective. We think that intelligent computing is really at the center of what needs to happen to enable the Internet of Things. It's about smarter clients. What do we mean when we say clients? We're talking about your tablet, your notebook, your console, your set-top box in the living room. All of these are clients that need to kind of enhance their intelligence and the way that we interact with them. It's about smarter clouds. The cloud that we connect to needs to get more intelligent. If you think about the diversity of traffic that comes in the Internet of Things, we need to make major evolutions in the way that we think about the cloud and the network. That'll be the bulk of what I talk about today. And then it's really about kind of to the point around smarter things that I think kind of the first couple of gentlemen and colleagues have covered quite well. It's about the experience and what do you see in the Internet of Things. To give you kind of my own personal story around kind of my latest Internet of Things interaction. So actually, at the end of last year, I had an opportunity to buy a new vehicle. And being from Texas, I had to buy a pickup truck, right? Everybody in Texas drives a pickup truck. So I actually had an opportunity to buy a pickup truck. And as I'm filling out the paperwork, and I'm kind of, giving them my name and address and bank account. I give them my email address, my phone number, and that type of thing. I don't think too much of it. I actually, kind of move on and go about my merry way. And then about 2 months into it, all of a sudden on kind of on my smartphone, I get an email from my pickup truck. Now, I didn't ask to get an email from my pickup truck, but what it told me is you have low tire pressure in one of your wheels. You may get a flat tire. It also went so far as to tell me that the nearest dealer was only 4 blocks away, and they happened to have appointments for service at 3 o'clock that afternoon. So when you think about all the things that happened there, the connection to the basic event, which was the tire pressure was low, was just the beginning of the potential that we see with Internet of Things. Think about that. Think about the intelligence that went into registering. What was that problem? Think about the business models that created. It actually created kind of a whole potential new revenue stream. So as exciting as the Internet of Things are, there's also a lot of exciting innovation around the computing that goes with it. And that's what I'll talk to you about today. So a little bit about kind of how networks work and how we kind of envision the Internet of Things evolving. So we kind of have the hypothesis that the traditional client-to-cloud network won't work for IoT. There's this vision or this idea that everything will connect to the cloud. And when you think about that, that could be everything from in the enterprise, whether you're talking about machines, you're talking about videos, in the home. We talked about and saw great examples from my prior colleagues in terms of different, smart lights, smart switches, video cameras, smart TVs, infrastructure, autonomous vehicles. And when you think about the challenges that this present, whether it's 20 billion devices or 50 billion devices that are connected to the Internet, if we send all of that data to the cloud, it's not very efficient. It means that you're sending data to the cloud that you really don't need to. It means that you're generating traffic and consuming capacity that really isn't necessarily needed. It means that you're wasteful in terms of the bandwidth and spectrum as we talk about wireless needs and the very crunch spectrum that we have in terms of some of the licensed spectrums. So, and to give you kind of some examples of that is back to the examples, some of my colleagues illustrated around kind of the smart home. So one of the kind of advents of the smart home is you may have a sensor that tells you kind of your door is open or your garage door is open. You may also have kind of surveillance in the home where people kind of actually now have kind of video monitoring. If you think about the types of data that you're going to be sending between those transactions, If your door is open or closed, that's a fairly binary thing. You don't need an analog signal. And it's not something that changes very often. You probably can, tell if your door's open maybe if you monitor it every second, every couple of seconds, every 10 seconds. But when you look at what you do with video, you're spending massive amounts of data across the network at kind of different rates and resolutions and speeds. So if you think about these two fundamental connections in the home, they're very different. And that's why we think that the network really needs to evolve to be able to support and embrace IoT. So what we see is we actually see that network evolution is key for the adoption of IoT. So what will happen is you'll start to see more computing technology and more intelligence move to the edge of the network. So think of the clouds that are kind of big and tall and all-encompassing now starting to move closer to the edge of the network. And what this will do is this will allow us to put smarter processing where it needs to happen. So think about the example that I talked about before around some of the smart home type application. You actually, when you look at kind of how this might evolve, you'll actually have all these different inputs that are going into some type of hub or gateway. Your hub or gateway, it might be your laptop, it might be your game console, it might be your wireless access point, but it won't be the wireless access point or the game console or the laptop that you have today. It'll have built-in intelligence that helps you analyze what are the different things telling me that I need to do. How do I process them? What do I need to do to react and monitor that? A good example of that is one of the colleagues did a great job before of talking about kind of energy management, right? In the smart home, you may see that, okay, based upon the sensors that I see in a room, I don't see that there's anybody in that room, so I should automatically turn off one of the lights. And it may be that you see that, that there's all these different abilities to optimize power at the home level. But think about how if you beam some of that data, not all of that data, up to another level in the cloud, then you have the capability to do analytics and look at trends at a neighborhood level, at a city level, that says this is what's going on, not just kind of in my local domain, but also kind of in a more global scale. And that's the interesting part of how data decision and analysis will occur in the Internet of Things. So the other thing to point out, apologies here, we're advancing the slides. When we think about the Internet of Things, we also think that the type of processing that you do will change. When I talked about kind of the diversity of the kinds of signals that you have, kind of again to build kind of on the smart home concept. When you think about whether it's a light switch, a smart TV, a video camera, your refrigerator, your appliances, they're all generating different types of data. And that means that the type of computing that you will need to apply will be varied. So for example, you actually may see that some of what you need to do is actually process multimedia, video streaming, right? You actually have the ability to kind of now do video streaming in the home. When you look at kind of the sensor inputs, you may need signal processing. These are all things that you'll start to see around the heterogeneous nature of computing in the network. So the other thing that will have to happen is this computing needs to be scalable, right? Because when you think about what we're going to do with these different applications is we're going to move from an area where the cloud does one thing, the access point does another thing, to where all throughout the network you're going to see equivalent and very similar levels of functionality and performance. And so when you look at this, scalability is very key because sometimes you may have needs where you need to kind of optimize very locally, back to kind of the smart home example. Another kind of good example is back to this idea of autonomous highways and kind of self-driving vehicles. You can imagine that kind of the latency, response time, quality of service, reliability is very different for that than simply your kind of smart and monitored home. The other thing that's interesting to think about is how this will play out is, as you're having all this critical data from the Internet of Things moving in and out of the network, is it secure? Is it really important that I know that my door is open at home? Do I want somebody to have that information? So it's about establishing security at the various different layers of the network as well. So really the scalability is going to be extremely important, and the heterogeneous architectures that are going to be developed are really going to enable kind of quite a diversification and scalability. So industry leaders are already adopting this transformation. I'm actually showing kind of a diagram here that happens to be from NTT, one of the leading telecommunications providers in the world that happens to be in Japan, around their concept of edge computing. So cloud computing, typical cloud client model is you have data applications that live kind of in the cloud, and you have devices that live kind of at the edge of the network, and you have traffic that goes back and forth. Well, in the idea around edge computing, or the idea around kind of the flattening of the network, is you move computing closer to the problem, which means that you save bandwidth, you provide better quality of service, you actually provide more intelligent operations to make your things even more intelligent. It also has aspects of kind of quality of service and latency. Back to the idea that I talked about is the smart home problem versus the autonomous driving vehicle and highway problem are very different. One needs higher reliability, one needs lower latency. These are all problems that are being fixed by adoption of these types of technologies. There are many different people that are embracing this approach. NTT, Cisco, with their fog evolution, is really kind of going a very similar direction of taking what historically has lived in the cloud and kind of building a fog that is more of a continuum towards the edge of the network. Okay, so the other thing to think about, so I've talked a little bit about kind of the need from a processing perspective. There really kind of are two fundamental architectures that dominate this space, ARM and x86. And these are actually undergoing kind of a pretty significant transformation as we talk through at the moment. When you look at historically the x86 space, which again is kind of AMD's heritage, this has historically been associated with very high performance, high power, cloud, server, client devices, networking. If you look at it, it's a very broad and established ecosystem, but really is kind of built fundamentally around Android, around Windows. You look at now kind of the ARM products and the ARM ecosystem. It has massive adoption in mobile, in the Internet of Things, in microcontrollers, in smartphones. Has a very broad and growing ecosystem, but really kind of now is attempting to kind of migrate up into networking and dense server, really with kind of a very strong base from an Android perspective. So really what we see happening is these two architectures and the markets they serve are really on a collision course. When you look at, as I talked about, ARM absolutely wants to move and is moving from the mobile space and the Internet of Things into the cloud, into the network. The same thing on the x86 side. We're now seeing more x86 tablets, smartphones, form factors, and Internet of Things that mean that we're on this collision course of ecosystem, which means that we should have a very interesting and broad ecosystem and coexistence of these two dominant architectures. So one of the things I wanted to share with you about AMD's approach to the problem is really a technology and a foundation that we've developed. So first, we actually saw this problem coming, the need for this kind of diversity of processing, whether it's signal processing, graphics processing, core processing, and really started work several years back around what we call the heterogeneous systems architecture. And the way that you think about this architecture is it's a very intelligent computing architecture that brings two very fundamental elements together. It brings CPUs and GPUs together. Well, you're probably saying, well, haven't applications processors been around a long time that do that? Absolutely they have. But it's always been in this model of the CPU is the master, the GPU is the slave. CPU is general purpose, and you have to be a boutique programmer to be able to do GPU processing. Well, what we're doing with this is we're now leveling the playing field. That the CPU and GPU can both coexist. They can both be masters. They can both be slaves. They share a memory subsystem. They have an approach of not just boutique graphics languages, but things like C and C++. So HSA allows us to take these two very powerful things that used to be dedicated concepts, CPU for control plane processing, graphics engines for graphics processing, and we can now think about the problem differently. We can think about serial problems that tend to focus and perform better on CPUs, and parallel problems that tend to be able to focus well on things like a massively parallel processor in the GPU. It really is about enabling this heterogeneous computing approach that we see as being prolific moving forward. So HSA is not just about AMD. HSA is a foundation that AMD helped start, which really started to bring industry leaders together around this heterogeneous computing problem. And you see many of the industry leaders, some of them on our panel, that are members of the HSA Foundation. And what this does is it allows us to come together as an industry and create standards where we can collaborate and kind of have some cohesion and uniformity, but also enough flexibility to differentiate. You can see that there's actually competitors on this slide, and that's kind of the key. Because if we don't have standards in the Internet of Things, we think it actually has the potential to become what we call the Internet of Babel, where you'll have all these devices in a spaghetti soup of connections with really not a lot of intelligence. So standards and things like the HSA Foundation allow us to collaborate on foundational capabilities and still, as companies, compete on what we think we're good at and what we differentiate in. It's not just about kind of theory. The thing that I wanted to share with you is these are products that we're bringing to market today. So in the first part of this year at CES, we brought forward the first HSA-powered device in the industry in our Kaveri. At G2E in Macau 2 weeks ago, we brought the first embedded device into market that has HSA capability in the Bald Eagle. These are things that people are developing on today. You see products at this show that are being deployed based upon this technology. And you're seeing our ability to bring heterogeneous computing to life. And it goes without saying, or it's maybe worth reiterating, I guess, is that to do this, you have to demonstrate a very high level of performance. And when the devices that we're bringing forward here actually are measured from a performance perspective, they actually provide very high performance levels with greater than kind of 2/3 of a performance speed up over and above the prior generation and the competition. So really, I wanted to leave you with this: is the Internet of Things is a really cool thing, right? Lots of things, and you saw a lot of great examples from my colleagues and panelists, partners, about kind of the things, and the things are really cool. But I also wanted you to understand that there's a lot of good things that need to happen in the network to enable these rich, interactive experiences, to make the things tell us what we need to know. With that, I thank you for the time, and I appreciate your attention.